Let's complete our lesson about transformer, and now we are going to talk about transformer equation. Let's remember first the structure of the transformer. The transformer consists of the iron core and two coils, primary voltage or the input VP and the secondary voltage output VS, primary turns, and we said that the turns is the number of the coil turns denoted by NP, and we have secondary turns NS. To study the equation, we must first know VP, VS, NP, NS, and we are going to give it to you in the problem and ask you, for example, I will give you VP, VS, NP, and ask you for the number of turns and the secondary turns, NS, and so on. Sometimes I ask you about the primary voltage, VP, and I give you VS, NP, NS. It's a very easy equation. We are going to study it now. Let's see now the transformer equation. The transformer equation states that VB divided VS equals NB divided NS. VB is the input voltage or the primary voltage. VS is the output or secondary voltage. NB is the primary turns. NS is the secondary turns. The output voltage of a transformer depends on the number of turns on each of the coils, as well as the input voltage. So, the output voltage, which is VS, depends on VB, NB, and NS. In other words, we can say that the ratio of the voltage is equal to the ratio of the number of turns. The ratio of the voltage, VB divided VS, equals to the ratio of the turns, NP divided NS. And now let's talk about high voltage transmission. When electricity is transmitted along overhead cables, it's done at high voltage. We are going to use, in that case, we are going to use two transformers. A step-up transformer is used to raise the potential difference or voltage before transmission, and then step-down transformer is then used to step the potential difference back down to the normal level when it reaches its destination. As we are going to see in the next diagram, here the power station. The power station produces electricity, and the electricity is transmitted at high voltage, which reduces both the current and the loss of the power. And then you are going to find here a step-up transformer. So high voltage, low current. And then you can find here step-down transformer. Why? Because it will enter to the home. So we wanna the amount of voltage that entering the home smaller than that come from the power station. So first step-up transformer, and then we are going to use step-down transformer to decrease the voltage to its normal level, as you can see here. Thank you for listening, and goodbye.